Hey everyone, it's Mr. Lucas. I'm still recovering today. It's Wednesday, March the 21st. We would have started chapter 7, access control list today. So I figured I would run through a video narration of our notes so that you can have a good understanding and grasp of it before we start this on next Monday, because we'll kind of hit the ground running and hopefully finish this up before we go on spring break the next week. All right, so we're going to start chapter 7, access control list. What is an access control list? The thing you want to think about when you hear ACL or access control list is filtering traffic. So we're either denying or blocking traffic from successfully making it through our router, or we want to permit or allow traffic to successfully go through our router. Now, when we think about our communication, we need to think about it from source to destination. We have been doing that since class 1. When we have like a PC talking to another PC, we want to think about, or even a server, we want to think about that from source to destination and everything in between. We want to be able to trace that traffic from end to end. So we're either trying to deny a source from talking to a destination, or we're trying to allow a source to be able to talk to a destination. Now, standard ACLs are all we're going to do here. There does exist a extended access control list, but we will not cover that in this class. That will actually be a later Cisco class, okay? So standard are the ones we want to focus on for IP version 4. There are IP version 6 access control list as well, but we're going to focus on IP version 4. Now, a standard numbered ACL you will see is numbered either 1 through 99. So when we configure them, when you do a numbered and you number it 1 through 99, your Cisco router automatically knows you're not talking about extended. The main difference between standard and extended are the criteria that you can set. Or you can number it 1300 through 1999 if you run out. We'll stick to this range, like the 1 to 99 range, okay? Because we won't have more than 99 ACLs on our router. Now, again, standard ACLs can only filter traffic, either allowing or denying, based off one criteria alone, and that is it. And that is, where is your traffic coming from, or what is the source of that traffic, okay? So that's the only criteria we can set. So when you set a ACL, and again, you specify it as if you're doing a numbered, you specify it 1 through 99, you don't need to tell the Cisco router, hey, this is a standard one, because it automatically knows with that number range, that's what it is. Extended is actually 100 through 199, or a much higher number than what we've got listed there. All right. Or you can name it. Okay. So there's named ACLs. Your names can contain letters and numbers. Usually, the recommendation is writing it in all caps. That's not necessary. That's not like a have to rule. The only thing you want to do in your packet tracers is, of course, make sure you have them case sensitive. So whatever the packet tracer says, that's what you need to name it. Your names cannot contain spaces though. So it's almost like your host names for your routers. Remember, if we want to do like multiple words and you be able to clearly see that, we might put a dash, we might put an underscore or something else in there to help it, but it cannot contain a physical space. And then you can add and delete entries. Now, the one thing that I would say is that when you are configuring an access control list, all right, is that you open up Notepad and you were to actually write them here or write them down on paper. The way an access control list works, standard or extended, is it works from top, and I'm going to put some symbols like this here, all right, down. So basically it starts up here at the top, and let me make this font a little bit bigger. All right, it works from top down. So literally you are like creating a list, okay? And it checks every time a packet crosses your router. If you've got an access control list, it checks that ACL to make sure that that specific packet doesn't apply there. Because if it does, then it may need to block or allow traffic depending on that. So it literally reads from top down. Okay. And I'll kind of give you an example in a second. Now, also, one thing to keep in mind is that at the very bottom, we call this an implicit, meaning you can't do anything about it. Like it's there. Once you set any access control list rule, this deny any statement goes at the bottom. You can't remove that. It doesn't matter if you've got deny or permit statements up here at the top. There is a deny any that automatically goes into effect. You don't see it on the router, but it is automatically there. So you really need to be intentional also about how you order these statements that you put in here. That's why a lot of people recommend you do this in Notepad or something first, because if you make a mistake on your router, then you're kind of creating double work for yourself of like adding and deleting entries and making sure they're in the right order. And all of that. So we'll get to that in a moment when we get to our example. Also, other than a standard ACL being only to filter by where the traffic is coming from, either the entire network or just one computer, we want to look at the placement of it. Okay. So we can only place a standard ACL on devices that we have control of. And that's any ACL. So remember, when we are looking at our network, there are certain devices we don't have control over. Like for instance, right now, I'm on my computer. I've got a wireless router and a modem over there. But once it leaves my house, I have no control over like the ACL of my neighbor or my internet service provider in Suddenlink or whoever it may be. All right. So everything that we do when we place an ACL, it must be in context of what we have control over. Okay. Now, because a standard access control list is only concerned with being able to filter traffic with the source IP address. So like I can't say, hey, if you're going over here, right? That's, I can't do that. I can only say, hey, are you coming from this place or that place? That's all I can do is where's my packet originating from. It is best practice to always place standard ACLs as close to the destination as possible. Now, again, that is dependent on what I have control over, but let's look at an example here. So in this example, we have a network, okay? We have R1, R2, R3. We know we have control over all of these devices, okay, from start to finish. We have 3 switches here. So we have a network here, 192.168.10.0, okay, /24, okay. That is R1, S1, and PC1. We've got a whole separate network here. They don't tell you on this like diagram here, but this is 192.168.20.0, which is R1, S2, and PC2. Remember, that's a whole separate network. Then we've got a whole separate network over here connected to R3. That's 192.168.30.0. Okay. So what they want to do is they want to prevent this whole 10.0 network. So that's all this stuff here, right? We want to prevent that S1, PC1, even if we added another PC5 over here off of S1, okay, that's in that same network. We want to be able to block all those devices, but still allow this network S2 and PC2 to be able to talk to PC3, but we don't want to allow PC1 and S1 and anything else we were to add off of S1 in this particular 10.0 network. We don't want to allow that to talk to 30.0. So how do we do that? Well, we would be able to create an access list. So that's where our commands come into play. Okay, it reads it from top down. So for this one, we particularly really need just 2 entries. Okay, all right. So remember, it reads it from top down, and I'm going to put in here our criteria or our goal. Okay, is to block the 192.168.10.0 network. That's when you see it represented as the /24, you know that's the whole network, okay? From contacting the 192.168.30.0 network, okay? We also want to permit all other traffic, Okay, that's going to be important. So when we start our command is access list. All right, if we're doing a numbered. Okay, the next thing we're going to do is the number. Again, we could use 1 through 99 here. All right, and let me make this font just a little bit. Well, let me just widen this out. All right, so access list 99. Okay, then it's going to ask you, do you want to permit, deny, or remark? Permit would be allowing the traffic. Deny would be denying the traffic. And then remark is, if you're a programmer, remarks are like making comments within your program so you can know what a line does. That's what a remark does, so that you, when you look back at it, you can see what it does. It doesn't actually affect anything. The permit and deny are the ones that affect anything. So let's look at our goal. We want to block 192.168.10.0, that whole network, from contacting 192.168.30.0. So the only criteria it accepts right here is your source network information. That is it, and you'll see that in your notes. So what we want to put here is 192.168.10.0. Now, next, we want to put our wildcard mask. We've never talked about wildcard mask before. A wildcard mask is the inverse of your subnet mask. So a /24, again, let me just make some notes down here. A /24 we know as 255.255.255.0. That's what we know, right? But a wildcard mask, and that's what we want to put right here. Okay. What we do is, to figure that out, we go up here and put 255 above every number we got, and we literally subtract it. So if we subtract 255 minus 255, we get 0. 255 minus 255 is 0 again. 255 minus 255, 0 again. 255 minus 0 is 255. This is our wildcard mask. So right here, I would want to put 0.0.0.255. Okay, that's what it's looking for right there. Okay, so again, we would take our subnet mask. Whoops. Okay, this is our subnet mask right here. And we just want to put all 255s above it. We subtract, and this ends up being your wildcard mask. Okay, that's why it's important. Carry around that subnetting cheat sheet, print one off. All right, make sure you know what your subnet mask is, and then if you know how to subtract, you can get your wildcard mask pretty easily. Okay, so that's where we get that from. We'll come back to more examples of that in a minute. So we've got access list 99. Okay, we put, this is our source network information, and that's it. So we can't put, like, if you're going to .30.0 network, we can't put any of that. It won't allow us to. So this is all it will accept. Okay, now I forgot right here. We need to put permit, deny, or remark. What are we doing? We are blocking that traffic. So we want to deny access, okay, for that. Now, there's an important thing here. All right, let's look. If we just left that statement, because that would, get us our first goal here of blocking that would be checked off, right? However, what'll happen here? So traffic will be flowing across, and it'll be flowing across from PC1 to PC3. It's going to get to R3. That's where we're going to place it, because this is the R3 device is as close to the destination. PC3, the network, is the destination as we can possibly get. So what'll happen is it'll get there and it'll say, are you from 192.168.10.0? Oh, well, if you are blocked. All right. But then what happens? All right. It'll block that. That's good. That's what we want. But what happens if it's like from the 20.0 network, right? If it's from PC2 going across, it'll say, all right, are you from the 192.168.10.0 network? Oh, no, you're not. Okay. Let's go to the next line. Deny any, right? That deny any is always going to be there. So if we want to permit other traffic, because right now we got deny and deny, that's it. It's not going to allow anything through. Okay. So what'll happen is we need to go in here and put access list 99 permit any. So it's kind of like building a list. All of them would have, if you know we're in the same kind of goal here, all right, we want to all be the same number, and then it's going to put them in order. So that's why I said it reads it from top down. So here, all right, what will essentially happen is, again, if you're from this network, it's going to deny you. If you're from anywhere else, it's going to permit you. So it will never get to this deny any at the bottom. All right. So we don't even need to worry about the deny any like being down there anymore, because we have this permit any. Now, of course, remember, it's all relative. You can't with access control lists set up like a robotic rule to say, oh, I'm always going to put permit any. No, that's not the case. It really depends on your goal, and you got to use your critical thinking caps here to really evaluate what's going on. What is your goal? Where is the traffic coming from? All of that stuff. Okay. Now we get that in there. That's great. Then we want to look at where do we apply this then? Okay. So if you want to apply it as close to the destination as possible, all right, you could apply it here on FA01. Okay. So you would literally go into R3, do interface FA01, and then you're going to type the command, which is listed down here. Okay, so interface, the interface number, so FA01, IP access group, then we're going to put our number, okay, or the name if you did a named one, and then you're going to put in or out. So the in or out part is usually what trips people up, okay. If you applied it on FA01, it will be going out to PC3, okay. So you want to apply it as close to the destination as possible. The reason being, if we applied it really close here, it may accidentally block certain traffic because we can't decipher like where are you going to. Okay, so you really want to place it as close to the destination as possible every single time with a standard ACL. All right. Now you can do a named ACL as well. So for instance, with that same example that we just set, let's say we did a named one. So right here, our command will be slightly different. Let me just erase them all together. Okay. So this time the command is IP access list. Okay. And then you will put your standard or extended. We're going to do standard here. Okay. That'll be the same. Everything's good there. Then you want to name it. So I could put like the 10 network ACL. Okay, whatever you want to be. Remember, you cannot put a space, so you need to either use dashes or underscores or something like that to separate it. All right. Then your command prompt is going to change. It'll say like standard access list right here, named access list. So now we're just straight putting permit or deny or remark. So then we put right here permit, or sorry, deny, because we're denying that traffic, 192.168.10.0. Remember, our wildcard was 0.0.0.255. Okay, so this is kind of like building a list as well. And then we do permit any. So it's still going to read that, and then down here at the bottom is still that deny any. So we have to be weary of that deny any there. All right, so depending on our goal. So then we put permit any here, okay, and it will still accomplish the same thing. So you can either do named or numbered. Now, how do I show this? Well, once you get your access list in where you have your pound symbol, all right, show IP access list. And what'll happen is it'll come up and it'll have sequence numbers in front of each line. So with the two we did, it'll say 10 deny, or it'll have your name of your access list or your number here. So it'll be like 10 network. Sorry, I can't type today. ACL. And then over here, it'll have each line 10 deny 192.168.10.0. And then it'll have your other line, and it'll say 20 permit any. Now, it will not have that deny any at the bottom. Now, what are these 10s and this 10 and 20 here? These are sequence numbers to like order the line from top to bottom, the reason it counts by tens, and this is all part of the same access list, even if you would have kept it the numbered one, okay, when we did it a while ago, where we did access list 99, right? It would have said access list 99. These sequence numbers are irrelevant of the name or the number that you assign this part, okay? These sequence numbers are for you to be able to go back and let's say, oh crap, I forgot a line in here. You could go in here and put like 11, all right? So you have technically what? You could add 11, 12, 13. You could add, 9 more lines in between here to be able to put other deny or permit statements in between if you were to mess up. Also, if you wanted to remove just one line, you could do no instead of removing the whole thing, like no access list. You could actually come up here and edit one line of it, okay? And you could just remove out the 10, okay? And you could do the IP access list standard, whatever name or number you got, and then I put no 10 deny host 192.168.10.99. What'll happen is it'll remove just that entry but leave this one. So the sequence numbers are really there for the system to just be able to number it from top to bottom. You could also add ones before this, right? You could add 1, 2, 3, 4, 5, 6, 7, 8, 9. Has nothing to do with the actual access list number though, okay? So again, the things you want to be worried about are that deny any at the bottom of the access control list. It's always there. You can't take it out. It's implicitly there is what it's called. But you also want to look at your goal. Now, what if my goal changed? Okay. What if I said in my, and this is the last thing I'll show you. What if I said in my access control list here, I only want to restrict PC1. Now, the way we've got it is we restricted the whole network. So even if new computers were to get added here, we restricted the whole network, okay? Even if like a 10.1, 10.2, the whole network, okay? But what if I said I only want to block PC1 only, okay? And let's say PC1's IP address was 192.168.10.12. Okay, we want to block that from contacting that other network. Okay, so what we could do is let's do the numbered way. Okay, so we'll do access list. Let's say we numbered it 99. Okay, deny, and instead of the whole network this time, before we would do 192.168.10.0. put the whole network, right? This time we'll only do that one and what we call host. So you can put deny host, and now it's just looking for an IP address. You don't even need a subnet mask or a wildcard mask here, okay? Then we still need that permit any here, okay, because that deny any is at the bottom. So using the keyword host, we can limit this to just one computer. Where is it coming from? So only blocking PC1. So if there was another PC off of this network here, like S1 had a PC5 over here, right, and it was 10.20, it would still work, but it would only block PC1. So it depends on if you want to block the whole network, all right, the source network, or do you want to just block one source PC or a host or whatever that one IP address is related to, okay? So the things to take away from this is standard ACLs are only able to block one criteria, and that is, or filter based off one criteria, and that is where is the traffic coming from, okay? It cannot filter based off where the traffic is going to. Also, when you place the ACL, you want to place it on the interface as close to the destination as you can possibly get. All right. Now, we will go over this more detail on next Monday. All right. I will hopefully be there this Friday if everything else goes well. With my recovery from the flu. So, contact me, email me if you have any questions. Next Monday, we will kind of hit the ground running. We've got 4 lab assignments in Chapter 7 that we'll go through next Monday and Wednesday during class. Those videos are actually already posted as well. If this video kind of was like, whoa, I want to try some of this stuff out, go ahead. Those videos are posted for the labs. Now, also make sure that you go back and read under Net 126, under our class. All right, read our assignments for Monday, and watching this video is going to be your assignment for today when we miss class this Wednesday, March the 21st. All right, so hope you guys are doing well out there. I'm feeling a little bit better each day, so hopefully I will see you guys soon. All right, take care and make sure you email me if you have any questions.